In this video, I want to talk about how to factor perfect square trinomials, difference of squares, and also sum and difference of cubes. Okay, the first one I want to talk to you about is perfect square trinomials. We have a plus b quantity squared, and we found in the previous section that that's a squared plus 2ab plus b squared. And then if you change the plus sign to a minus sign, a minus b quantity squared, that's a squared minus 2ab plus b squared. So we need to use these formulas to be able to factor trinomials like this. Let's look at some examples. So here I have x squared plus 8x plus 16. Okay, well, the first thing to notice is that x squared is a perfect square. Whoops. So that's a square, and 16 is a perfect square. Well, x is a perfect square, x squared is a perfect square of x, and 16 is a perfect square of 4. So this is most likely x plus 4 quantity squared. Now I should check my cross terms to make sure that this in fact is what I think it is. So the cross terms would be 2 times x times 4. Well, what's that going to be? But 8x. And that's exactly what I need it to be. So that's the answer. Okay, now let's try the other example. X squared plus 14x plus 49. Well, this is a leading coefficient of one problem, but I want to show you that this is also a perfect square trinomial. So x squared is x squared, literally, and then 49 would be 7 squared. Okay, so this is most likely x plus 7 quantity squared. Okay, we should check those cross terms and make sure that those work. So I'll do those to the side. The cross terms would be 2 times x times 7, and that would be 14x. That's exactly what we need them to be, so this works. Okay, let's go on. So for this one, very similar. We have 49x squared plus 140x plus 100. Well, if we used other techniques, we'd have to use the AC method, and that's going to be very painful to do because we'd have to find the factors of 4900 that equal 140. You still can do this, but if you recognize that 49x squared is 7x squared and 100 is 10x squared, then you might be able to see that 7x plus 10 squared is the correct answer. Okay. Let's check the cross terms. 2 times 7 is 14 times 10 is 140x. So that works. That's the answer. Let's try this one. 4x squared plus 12x plus 9. Okay, well, 4x squared is 2x quantity squared. And then we have 9. Well, that's 3 squared. So this is most likely 2x plus 3 squared. All right, well, 2 times 2 is 4x. Plus times 3 is 12x. So this works. This is the final answer. I didn't have to use AC method for that one. Now let's talk about the difference of squares. In a previous video, we talked about how if you multiply these out, the cross terms cancel, and it's really just a squared minus b squared. So let's look at some examples similar to what we did before, but backwards. So x squared minus 81, well, x squared is a perfect square. It's literally x squared. And 81 is a perfect square. It's 9 squared. So this is most likely x plus 9, x minus 9. Okay? And in fact, that is what happened. So if you redistribute, you'll get this binomial back, but this is fully factored. Okay, what about this one? 121y squared minus 144. Well, 121y squared would be 11y squared, and 144 is 12 squared. So this is 11y plus 12, 11y minus 12. And that would be the factored form, difference of squares. Okay, 25y squared minus 144x squared. It's pretty much the same thing, except the x squared. Here, this has a variable, so there's two variables we have to watch out for. But 25 is 5 squared, 144, as we know, is 12 squared. So this is most likely 5y plus 12x, 5y minus 12x. And in fact, that does work out. Okay. What about this one? 49 minus 3x squared. Well, the variable's on the other end here of the binomial, but that's okay. That's no big deal. 49 is 7 squared. So 7 plus 6x, 7 minus 6x. There, it's just about identifying which type we're looking at. This one is a little bit different. We have x plus 5 quantity squared minus 144. So this is still the difference of squares, except it's kind of confusing because the x plus 5 is the square now. So this would be x plus 5 plus 12, x plus 5 minus 12. 12 is coming from the 144. Okay, from there I can simplify, and we have x and 5 plus 12, well, that's 17. And then we have x, 5 minus 12, well, that is 7. So we have x plus 17, x minus 7. If you redistribute this, you can get this back. Okay, let's go on to this one. 100x to the 4th minus 9t squared. Well, 100 is 10 times 10. X to the 4th would be x squared times x squared. So this is 10x squared squared. And then 9t squared is going to be 3t squared. So I think this would be 10x squared plus 3t, 10x squared minus 3t. Okay. All right. Let's try this one. 150x times y squared minus 216 times x. Well, this is a little weird because, well, 150 is not a square, and 216 is not a square. So something's going on. I noticed that this has an x and this has an x, and they're not squared. So we could at least factor out the x. Is there a number, is there a greatest common factor that we could factor out with that x? And I think there is. I think we could factor out a 6. So I'm going to factor out 6x. What would I leave behind? Well, that would be 25y squared minus 36. And there we go. There's our difference of squares right there. So I can rewrite those, leaving the 6x out over here. 5y plus 6, 5y minus 6. And there it is. That's our answer. Okay. Well, what about 36x to the 4th minus 49y to the 4th? Well, that's not too bad. We just have to know that x squared times x squared is x to the 4th. So this would be 6x squared plus 7y squared, 6x squared minus 7y squared. Okay, that one wasn't too bad. Let's move on. 81 t to the 4th minus 1. Okay, well, let's see what happens. 81 is 9 squared. T to the 4th is t squared squared. So this would be 9t squared plus 1. 9t squared minus 1. Okay, well, it takes some practice to see, but we're not actually done, because this here is also a difference of squares. 9t squared minus 1, well, that's 3t squared, and then this is 1 squared. So I have to go one more step. So I copy that down, and I'll break this up into difference of squares. So 3t plus 1, 3t minus 1, and there it is. That's our final answer. It takes a little bit of practice, but if you notice that this is a square, which it's 3 to the 4th, and 1 can be as high as you want to go. It takes a little practice to notice it, but that can be broken down again. Now, the sum of cubes. This is the more complicated formula, but once you get a hold of it, it's not too bad. So this is the sum of cubes. A cubed plus b cubed can be broken up as a plus b times a squared minus ab plus b squared. Thing to note is that if it's adding here, it's adding here. And then these are always the opposite sign, and then you have always positive there. So the difference of cubes is the same thing, except we switch the signs. So it's difference, so you have a difference here, it's the opposite sign here, and this is always positive. Okay, if I want to write out just one formula, I could write out a cubed plus or minus b cubed equals a plus or minus b, a squared minus plus, it has to be the opposite, ab plus b squared. That's always positive. So this is a more condensed version of the formula, but you can choose which one you want to use for your own homework. Okay, let's look at this one and see what we can do. X cubed plus 27. Well, is 27 a perfect cube? Yeah, it's 3 cubed. So I could break this up as x plus 3, x squared. Then this has to be the opposite sign, 3x plus 9. Okay, not 3 squared, but 9. We have to actually write 9. Okay, so that is factored. What if it's the opposite sign in the middle? What if it's difference of cubes? Well, it's the same answer, it just has different signs. So this is x minus 3, x squared, then plus 3x. It has to be the opposite sign, plus 9. That last part is always positive because it's squared. Okay, so that's what happens if it's a different sign in the middle, sum and difference. Let's try this one, x cubed minus 216. Now, what do you see we could do? Well, is 216 a perfect square? Or it's not a perfect square, but is it a perfect cube? Yes, it is. It's 6 cubed. So we have x minus 6, x squared, opposite sign, 6x plus 36. And there we go. Factored. What about x cubed minus 125? Well, for here, we have 5 cubed. So I can say that this is x minus 5, x squared, opposite sign, 5x plus 25. Okay. Again, we can't write 5 squared. We have to write 25. Okay. What about this one? 125 x cubed minus 8. Well, is 125 a perfect square? Yeah. Is 8 a perfect square? Yeah. I'm sorry, I'm saying cube and cube. These are cube. I have a habit of saying squares all the time. So 5x minus 2, 25x squared. Then we have to multiply these together. So 10x plus 4. Okay. So that would be the final answer there. Okay. What about this one? X to the 7th plus 27x to the 4th. Well, x to the 7th isn't a perfect cube. X to the 4th isn't a perfect cube. 27 is, though. So what can we do? Well, I noticed that there's a greatest common factor. I could actually factor out x to the 4th here. And if I do that, I get x to the 3rd plus 27. And actually, we've already done this, so we just need to factor this part out. So x to the 4th, x plus 3, x squared, opposite sign, 3x plus 9. And there is our final answer. Don't forget the x to the 4th on the outside. All right, I'm going to leave you with a little question. Why is there not a sum of cubes? And I wrote, sorry, I meant squares. Why is there not a sum of squares? So a squared plus b squared. Why does this not exist? So for our difference, we were able to find a plus b, a minus b. We have that as a squared minus b squared, right? And what else? We also have perfect square. So we have a plus b equals a plus b squared. We have that formula, right? And then we also have a minus b squared. Why don't we have a squared plus b squared? Why can't we have that? So I'll leave you with that question, and I'll let me know in the comments or in the discussion of what you think of why that is true. All right, talk to you later.